Hey guys, and welcome back. So in the last video, we took a look at the replica set resource here, and this is essentially a manager of pods, and pods are essentially managers of containers because each pod spec has a definition of how many containers it's going to have inside of it, and when a pod is scheduled onto a node, it's basically responsible for spinning up the containers that make up that pod. So if we have our pod kind of at the base level here, and then we have a replica set, which is kind of one step above our pods, we also have the deployment resource, which is one step above that. So we're going to take a look at the deployment and how it can actually manage multiple replica sets for us. And this is really useful if you want to do things like rollback scenarios. So if you want to basically have a new version of your replica set that has, a different version of your application, maybe we change the Nginx tag from 1.18 to 1.21.0 instead. So that's kind of just changing the version of the web server that's running. Of course, that could be an actual private image of an application that you are personally building and deploying, but you kind of get the idea how we're changing the version here, and then we're redeploying our replica set and expecting it to deploy new pods with a new version of our application. In fact, why don't we go ahead and do that here? So in the last video, we just kind of looked at scaling in terms of the number of replicas, but if I actually change the version to 1.21.0, and then do another apply command here, just keep an eye on our pod IDs, so 28D and DZV. So eventually those will actually disappear. Now the replica set itself is not actually updating the pods, even though we updated the image version that we told it we wanted to use for Nginx. So we could just go ahead and manually kill off these pods. So we'll do a kubectl, and then we'll say delete pod, and I'll actually just copy the name of each of these here. I'll do the first one, and then the second one here as well. And actually, I'll just delete one for now. And then if I do a kubectl get all, we should see that the replica set finds out that only one pod is running, and so it should spin up another pod. And so sure enough, you can see it's running right here. And so if we do a kubectl describe on that pod, then we should see that it actually downloaded the latest image here. So it downloaded 1.21, and it's using that instead of our 1.18. And if we look at the other container, we can see that the other container is still running 1.18.0. So if we were to kill off that container as well, then we could ensure that both of our pods are running the same version. So we'll do a kubectl delete, and then we'll let the replica set go ahead and spin up another pod with the newest version of the Nginx container that we specified in our replica set configuration. So the replica set is kind of helping us to ensure that a certain number of replicas are running, but what it's not doing is it's not helping us to migrate to a new version of our application. And that's where the deployment resource comes into play, because the deployment resource, once we change our version of our application, our image that we want to run, then the deployment controller will handle rolling that out for us by creating an entirely new replica set and then scaling them for us. So let's take a look at the deployment resource. So I'm going to head over to our Kubernetes docs here, and then under workload resources, we'll go over to deployments here. And as you can see, deployment provides declarative updates for pods and replica sets. And they kind of talk about in the documentation here some of the different use cases that you have for the deployment resources. So for example, one of the most common is to simply use a deployment to roll out a new version of a replica set. Also, you can do things like rollbacks as well. So if you've deployed a new version of your application, but then you've changed your mind and said, oh no, we actually want to go back to the old version, because the deployment is actually managing multiple replica sets on the Kubernetes cluster, it can actually make it much simpler to roll back to a previous version of your application. Also, the deployment, because it is managing replica sets, it can help you to do scaling here as well. And you can also do things like pausing the rollout of a deployment if you need to make changes to the deployment and then redeploy it again if you encounter a problem during one of your deployment processes. So the deployment is just another type of resource that we can submit to the API server. It has a kind of deployment, and it has an API version of apps v1. And as you can see down here, we have under the spec section, we have a definition of what's actually a replica set. So we have our pod spec that's buried way down here under the template. And then right here under replicas, you probably saw that come over from the replica set definition that we looked at in the last video, where we were scaling up and scaling down the number of replicas that our replica set has. And then the other properties that we have right up here are just a name for the deployment. And of course, we have our labels for it here as well. So let's go ahead and try out using a deployment to control the rollout of our application instead of just using a standalone replica set. So the first thing I'll do is just copy this, and then I'll start by cleaning up the replica set that we had previously created. So it's called My Web Application right down here. I'll just go ahead and copy that and do a kubectl delete on that replica set. And then that should clean up my pods as well. Let's say kubectl get all, just to make sure our pods get cleaned up. And sure enough, it looks like they are terminating just fine here. So now I'll go ahead and create a new file here, and we'll just go ahead and save that to a file path like deployment01.yaml. And then I'm going to go ahead and paste in the deployment over here. So we'll just do paste on the deployment. And then let me minimize my terminal so we get a bit more screen real estate. And what we want to do on the deployment here is basically configure a name for it for starters. So let's call this Trevor Web App. And of course, you can use whatever name you'd like to call it right there. And then for app here, for this app label, I'm just going to call it Trevor Web App as well. And then for our match labels right down here on the replica set, we'll go ahead and just use that same value for that, as well as our pod metadata here. So our labels for our pod, we'll give it that name as well. And then down here, you can see we've got our pod spec, and we'll just set this to something like 1.18.0 for starters. And I'll set my replicas to, let's say, 5. So let me just save this deployment, and then we'll go ahead and deploy this out to our cluster. We'll do a kubectl apply. Oops, I don't have autocomplete enabled for it. -- file name, and then deployment01.yaml. So this is going to look substantially similar to the replica set, because essentially all the deployment is doing is creating a replica set for us. So as you can see, all we have right here is a deployment resource that indicates how many pods we want in our deployment. And then down here, it's created a replica set for us, and it's dynamically named that replica set. And it's also dynamically named our pods here as well, just with a unique identifier for this particular replica set. And this particular replica set has 5 desired pods, and there's currently 5 in the ready state. So these are all pretty healthy, and our deployment is good to go. Now we could use the deployment to scale things just like we did with the replica set. So let's create a new replica with 10 instead of 5. And so if I just redeploy that with 10 pods instead of 5 replicas, and then we come back and do a get all again, you'll see that we have now 10 pods up and running. It scales very, very quickly here. And basically the deployment saw that we didn't make any configuration changes to our replica set aside from the fact that we wanted to scale it. So it didn't actually create an entirely new replica set at this point because we haven't changed the version of our application. All 10 pods here are still running the same version of our application. However, if we were to deploy a new version of our application, then that's where the deployment controller would see that we changed something about our pod spec right down here in our replica set configuration, and it would then create an entirely new replica set and slowly migrate over to that new replica set. So we'll take a look at how that works in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.